Hello, my name is Shehryar Sardar, and this is my Physics 2211 Lab 5 Orbits Extended. Here is my table of contents with introduction, models, orbit code, discussion, and conclusion. The purpose of my lab is to simulate the mutual orbit of three bodies, a planet, a moon, and a ship, of the same mass around each other in three dimensions. Fundamental physics principles. First, Newton's second law. Force is equal to the mass times acceleration. Second, Newton's third law. For an applied force on an object, it will occur a force in equal and in the opposite direction, so F1 is equal to negative F2. Models. First, we have the universal gravitational force, which is equal to the gravitational constant times the mass of 1 times the mass of 2 over the radius between the two squared times negative r hat. Then we have the updated equations for velocity and position. Here is our results preview of the three masses mutually orbiting each other. As you can see, the objects not only move left, right, up, and down, but also forward and back, showing that it's in all three dimensions. Moving on to our initial values. For the initial values, I set the positions of the objects to be in line in the x, y, and z dimensions. Next, for the masses, I kept them all the same, so the forces would only depend on the radius. And lastly, for the ship, planet, and moon velocities, I set the speeds in each direction to be the same in magnitude. However, the directions differ, so they don't instantly collide on start by immediately pulling into each other, which would also happen if the velocity was all zero. Moving on to the loop, for the first part, we need to find all the forces acting on all three masses. This requires the gravitational force of the moon on the ship and planet, the ship on the planet and moon, and the planet on the moon and the ship. For the second part, we update the velocity and position based on the forces and their update equations. Here is a demonstration of our orbit code once more. Moving on to our final results. In our video, we saw how each of the objects orbited around each other, and there was multiple cases where two objects would do a small orbit around each other and then slingshot off, as since they were really close, the forces were very high, which would update the velocity a lot and shoot them far off. And some similarities and differences with mine and the original model based on Lab 3 was that in this case, I had gotten rid of collisions, so we wouldn't have to deal with situations of collisions, which would be more likely with more objects. And all three were of the same mass, so the gravitational forces were relatively similar. And the planet wasn't fixed, which would also change how the orbits would function and make it more unpredictable. Possible sources of error could be improper velocities, because some would just shoot them off into space. Moving on to our discussion questions. First off, what would happen if it was three objects of different masses, similar to in Lab 3? However, all would be free floating and none would be in a fixed position. In the case of different masses, some objects would be more likely to be pulled into the bigger objects, the higher mass objects, and this would cause for higher chance of collisions and masses being flung away from each other whenever two planets are close to colliding with each other. What would happen in a system of more than three objects? If there was more objects, it would add to the unpredictability of the entire system and make it more chaotic in a general sense. In conclusion, we have simulated the orbit of three objects freely orbiting around each other in space in all three dimensions. I hope you all had a good year this year and enjoyed my presentations, and have a good day.